Hello dear students, in this video I'll continue with the 8th chapter, which is linear programming problem. I'll continue with solving a linear programming problem using the corner point method. In this video we will see an LPP question which was given in this year's sample question paper for CBSE Class 12 Applied Mathematics. So here is the question which is given in section D. It carries 5 marks. It says Rahul is at the wholesale market who purchased folding tables and chairs to later sell them at his furniture shop. He has only rupees 5,760 to spend and his van has space to carry at the most 20 items. A table costs him rupees 360 and a chair costs rupees 240. Back at his shop, he plans to sell a table at a profit of rupees 22 and a chair at a profit of rupees 18. Given that he can sell all the items that he purchases, how many tables and chairs shall he purchase in order to maximize his profit? So here we can see that Rahul wants to maximize his profit. We need to find the number of tables and chairs that should be bought by Rahul in order to maximize his profit. Here we have the constraints. He has only rupees 5,760 to spend and his van has space to carry at the most 20 items only. And then the next constraint is a table cost him rupees 360 and a chair cost him rupees 240. Then here we have the information for the objective function. He plans to sell a table at a profit of rupees 22 and a chair at a profit of rupees 18. So with all these information, we need to find the number of tables and chairs that Rahul should purchase so that his profit will be maximized. First, let us write the mathematical formulation of this linear programming problem. So let us take, let the number of tables and chairs be x and y respectively. So here this is a profit maximization problem. So the objective function is to maximize profit. Z is equal to, here it is given, he plans to sell a table at a profit of rupees 22. So he will be able to sell these x tables at a profit of 22x. And he plans to sell a chair at a profit of rupees 18. So in that case, he can sell y chairs at a profit of 18y plus 18y. So this is the objective function. Maximize profit Z is equal to 22x plus 18y. Subject to the constraints. Now what are the constraints? The first constraint is with respect to space. His van has space only to carry at the most 20 items. So he has to purchase tables and chairs not exceeding 20. As a result, the first constraint is x plus y less than or equal to 20. So this is the first constraint. Then the second constraint is with respect to the amount he has. He has only rupees 5,760 to spend. And here we have the information about the cost of each table and each chair. A table cost him rupees 360 and a chair cost him rupees 240. So here we have 360x plus 240y. This should be less than or equal to 5,760. Now this whole inequation we can divide by 120. So we get 3x plus 2y less than or equal to 48. So this is the second constraint. And then we have the non-negative constraints, x comma y greater than or equal to 0. So these are the three constraints. And now we have completed with the mathematical formulation. As I already mentioned in the previous video, the the mathematical formulation of the given linear programming problem, it carries 1.5 marks. So writing the mathematical formulation carries 1.5 marks. Now let us draw the graph. Let us mark the axis, x-axis and the y-axis, and let us take the scale as 1 centimeter as 5 units. Now we have the first inequation. Let us draw the line corresponding to x plus y equal to 20. So for the first equation, x plus y equal to 20, when x is 0, y is 20, and when y is 0, x is 20. So this is the point 0, 20, and this is the point 20, 0. Now let us draw a line joining these 2 points. So this is the line corresponding to x plus y equal to 20. We need to find the region corresponding to x plus y less than or equal to 20. So if we substitute the coordinates of the origin 0, 0, we substitute x as 0 and y as 0, we get 0 plus 0 equal to 0. It is less than 20. So the origin lies in this region x plus y less than or equal to 20. So the region corresponding to this inequation is this part. So this is x plus y less than or equal to 20. It is this part. Now we have the next inequation 3x plus 2y less than or equal to 48. So let us draw the line corresponding to 3x plus 2y equal to 48. When x is 0, y is 24, and when y is 0, x is 16. So 0, 24 is somewhere here and 16, 0 is somewhere here. If we draw a line joining these 2 points, we get the line corresponding to 3x plus 2y equal to 48. We need to have 3x plus 2y less than or equal to 48. Again, if we substitute the coordinates of the origin and check, we have 0 plus 0, it is less than 48. So the origin lies in the region corresponding to this inequality. So we have 3x plus 2y less than or equal to 48. It is this part. Then we have x greater than or equal to 0 and y greater than or equal to 0. It is the first quadrant. So it is this part. So the region which is common to all these inequalities, it is this region. So this is the feasible region. Feasible region is nothing but all points in the feasible region will satisfy all these constraints. So that is the meaning of feasible region. And now after finding the feasible region, we need to find the value of x and y that will maximize the profit z. Now we know that if the feasible region is bounded, then the maximum value and the minimum value of z will occur at one of the corner points. So to know that, we need to know each of these corner points. So this corner point is the origin, it is O 0, 0, and we know the coordinates for this corner point. Let us mark this as A, let us mark this corner point as B, and this as C. The coordinates for A is 16, 0. The coordinates for C is 0, 20. And now we need to find the coordinates for B, this corner point B. If we draw this on a graph sheet, we will be able to get this coordinates directly. Otherwise, this B, it is the point of intersection of this line and this line. So if we solve these 2 equations, we will be able to get the coordinates for B. So here we have 3x plus 2y equal to 48. If we multiply this equation by 2, then we get 2x plus 2y equal to 40. So if we subtract, we get x as 8. When we substitute x as 8 here, we get y as 12. So the coordinates for B is 8, 12. So this is the coordinate for B, 8, 12. And now drawing the graph, finding the feasible region and the corner points, and then getting the coordinates for each of these corner points, all these carries 2 marks. Now let us proceed with finding the value of x and y that will maximize z. Here we can see that the feasible region OABCO, it is bounded. Since this feasible region is bounded, the maximum value of z will occur at one of the corner points. So let us draw this table with corner point in one column and finding the value of z in the next column. Z is 22x plus 18y. So the various corner points are O0, 0, A 16, 0, B 8, 12 and C 0, 20. Now the value for z when x is 0, y is 0 is 0. Then the value of z when x is 16, y is 0, it is 22 into 16. So it is 352. And then the value of z when x is 8 and y is 12. It is 22 into 8 plus 18 into 12. This when we simplify, we get it as 392. Then the value of z when x is 0, y is 20. It is 18 into 20, which is 360. So this is the maximum value. So we can see that the maximum value of z occurs at the corner point B 8, 12. So here x is equal to 8 and y equal to 12 will maximize the profit z. So the result is buying 8 tables and 12 chairs will maximize the profit. So this is what we have to find. How many tables and chairs shall he purchase in order to maximize his profit? So if he purchases 8 tables and 12 chairs, his profit will be maximized. So here finding the value of z at each of the corner points and writing the result. This part carries 1.5 marks. Total of 5 marks. So writing the mathematical formulation carries 1.5 marks. Then drawing the graph, finding the feasible region and marking the corner points, all these carries 2 marks. Then finding the value of z at each of the corner points and finding the optimal feasible solution and writing the result. It carries 1.5 marks. So we have 5 marks for this question. I hope this video was useful for you. I have already solved the questions from 1 to 6 from the linear programming problem exercise in the CBSE Handbook. The links are available in the description. In the next video, we will see how to solve a linear programming problem using isocost or isoprofit method. If you have not subscribed to my channel, please subscribe. Thank you for watching.